Okay, before we move on further to our project, let me introduce my group member. For the first one is Muhammad FARHAN bin Muhammad FUAD, and me, AIMAN NURHAKIMIN bin AZLIN SHAH, Muhammad Adam FAIZ bin NORHISYAM, and for the last one is Muhammad NABIL bin Muhammad NASIB. Bank Sepanan Nasional located at Jalan Guenang, Bandar Seberang, Segamat, Johor. For the operation time that there's an operate will be 9 AM until 4:30 PM. We set our observation time at 11 AM until 12 PM at the range of 1 hour. For the number of server will be 3 server.
Next, we will proceed to the characteristic of queuing system. For arrival characteristic, the size of the calling population is infinite, which means it is not fixed. The customer can arrive at a bank at any time. The pattern of arrivals at the system by using Poisson distribution is 16 customers per hour. Meanwhile, for behavior of the arrivals, it is a patient customer. The customer will be given a waiting number and wait patiently in the queue until their waiting number is called. Next, waiting line characteristic. First, the length of a line is unlimited. Second, for queue discipline, it is a priority queue. Even though every person that arrive are given a waiting number, if one has a higher priority, they will be served first. Service facility characteristic. Based on number of channel, we can see that this bank apply a multi-channel system which consists of 3 servers, and yet they use a single phase system. The process will be like this. The customer will wait for their turn, and then they will be called to be served, and then after the process is complete, they will leave the bank. Furthermore, we can see that the number of waiting lines consists of a single waiting line. Basic queuing configuration system. Based on our observation, we can conclude that this bank uses a multi-server, single-line, single-phase system. The customers will be given a waiting number, and there will be 3 counters that are being prepared to serve them. Once their waiting numbers are being called according to their waiting number turn or priority, they will be served. After that, the process is complete, and then they will leave the bank.
Okay, I will explain about the calculation, which is the result, and we will find the utilization factor. Okay, we will use this formula, which is P equal to lambda over S times with mu, and the result will be 0.8889. Next, we will calculate the probability number customer in the system, which is P. We will use this formula and insert the value, and the answer is 0.028. Okay, now we find the value of the average number of customer in the queue, which is LQ. Okay, to find the LQ, we must use this formula and insert it, which is LQ we get 93.3729, and run off it, and we will get 7 customers. Next, we will find the L, which is L equal to LQ plus lambda over mu, and we insert the value first, and we will get 9.0396, and run off, and we will get 10 customers. Next calculation, the average time customer spent in the system, which is W. W equal to L over lambda, and insert the value W we will get 0.565 hours. We convert into minute and we will get 33.9 minutes. Next, we will find the average time a customer waiting in the queue, WQ. WQ equal to LQ over lambda. Insert the value, we will get WQ equal to 0.3983 hours, and we convert it into a minute and we will get 23.9 minutes.
Assalamualaikum and hi everyone. My name is Muhammad Arif Malaysia. So I will teach you how to use the QM formula for this project. So first of all, we choose the module and then click waiting lines. So in the file menu, we choose the fifth option, which is MMS. So the title, we just put any title that we want. So I just pick 1.0. And the cost analysis is no cost because we don't use any money to produce or gather the data. So we just proceed with OK, and then we get this type of interface. So in the interface, we put the cost analysis as no cost, and then time limit based on our preference. So we just put it as 4 hours. So then we need to input the data. So for our rate, for us we get 16, and then the service rate is 6. And then for the number of servers, we have 3 servers, 3 customers. Now we get the data result after the solution button, and then we get the average server utilization is 0.89, and then our average number in the queue for LQ is 6.38 customer, or we can estimate the customer is between 6 until 7 customers. And then we get the average number in the system. We also call it as L, and then the value for L is 9.05, or we can estimate it as 9 until 10 customers. So we also get the average time in the system, which is WQ. We get the 0.4 hours, or we can convert into the minute, and we get 23.93 minutes. And in the average time in the system, which is W, we get the hours is 0.57 hours, and then in the minute is 33.93 minutes. Other than that, we also get the suggestion for server that then we get the optimum service. So the suggestion, the bank should have 7 servers to have the optimum service, and then like we see in the 6 and the assistant of 6 and 7 server, there is no average time in the queue the customer need to wait, which is 0.0. So if there is 6 server or more, the time that the customer need to wait for the next service or the third service, that's not taking too much time. We also get to see in the 7 server, we get the average number in the queue, LQ, is 0.01. So number for the queue to wait, that's not too much to compare with only 3 servers. So we also get the graph, and then we also get the table of probability, like if there is 0 customer, the probability is 0.03 and 1 is 0.00, and then so on. So I guess that's all for me. Thank you for hearing me, and Assalamualaikum.
As the conclusion, what we can comment on the number of server provided and the customer the waiting line for the question 1 is the number of server provided adequate? Our answer will be yes, because the average service rate per hour is greater than average arrival customer per hour. For the second question will be, the customer are happy with the waiting line? So our answer will be yes, because the customer doesn't have to wait too long to be called. So what we can learn from this project is, if we want to run a business, we must have the average service rate per hour greater than average customer arrival rate per hour, so that we can run the business efficiently. So that's all from me. Thank you for watching and see you next time.